Welcome to The Explainer. Today, we're breaking down a really fascinating intersection of environmental science and corporate accounting. We're going to explore how invisible air emissions in the midstream oil and gas sector actually have very visible, completely measurable impacts on both local environments and corporate finance. So if you've ever wondered how air quality directly translates to the bottom line, well, you are in the exact right place. Okay, let's dive right in by challenging a common assumption. When most of us think about environmental risks in oil and gas, our minds almost immediately jump to liquid spills, right? A pipeline burst, oil on the ground, or a slick in the water. But as the SASB sustainability accounting standards point out, some of the absolute biggest yet easily overlooked risks in the midstream industry aren't spills at all. They're invisible air pollutants that create massive financial and regulatory liabilities.
Section 1. The Midstream Emission Challenge.
To set the stage here, we're talking about pure-play midstream activities. These are the vast networks that gather, process, transport, and store natural gas, crude oil, and refined products. And across this incredibly massive infrastructure, emissions are just generated constantly. You've got exhaust from heavy-duty compressor engines pushing gas through miles of pipelines. You've got venting from oil and condensate storage tanks. There are emissions baked right into natural gas processing facilities, plus those sneaky fugitive emissions, the microscopic leaks from valves and flanges. And of course, we can't forget the mobile sources, like the barges, trains, and tanker truck fleets constantly on the move. It is a continuous, multi-source puzzle.
Section 2. Meet the primary pollutants. Now, to truly understand this hidden bottom line, we need to look past general greenhouse gases and zero in on the primary air pollutants. According to the SASB standards, the midstream sector has to accurately account for four major categories, basically the big four. We've got nitrogen oxides, or NOx, sulfur oxides, or SOx, volatile organic compounds, known as VOCs, and particulate matter, specifically PM10. And it's absolutely crucial to note here, operators are required to rigorously track and report these emissions in metric tons. They need hard, quantifiable data.
Let's actually look at how specific these definitions get. Take volatile organic compounds, or VOCs. The standard defines these as any carbon compound that participates in atmospheric photochemical reactions, with just a few specific exclusions like methane and carbon dioxide. Because they react with sunlight to literally create the smog you see hanging over cities, VOCs present some highly complex measurement and mitigation challenges for these operators.
And then we have PM10. This refers to airborne solid or liquid materials that are incredibly small, having an aerodynamic diameter of 10 micrometers or less. To put that into perspective for a second, that is literally a fraction of the width of a single human hair. Because they're so incredibly fine, they can be inhaled deep into the lungs, which creates highly specific environmental and community health concerns wherever these midstream facilities operate.
Section 3. Localized health and environmental risks.
So, what does this all mean? Why do these specific emissions, the NOx, SOx, VOCs, and PM10, matter so much to regulators and the folks living near these facilities? The absolute crucial word here is localized. See, unlike global greenhouse gases, where a ton of methane emitted over here has a global climate impact over there, the risks associated with pollutants like sulfur dioxide and nitrogen dioxide are highly localized. If a compressor station is pumping out high levels of NOx or VOCs, it directly and immediately impacts the air quality, the environment, and the health of the specific community right next door. Moving on to Section 4, the financial cost of emissions. And this brilliantly illustrates the invisible bottom line. Because these health and environmental risks are highly localized, they instantly trigger intense, location-specific regulatory scrutiny and operational friction. It goes from being an environmental issue to a financial one in a heartbeat. Amid all this increasing public and governmental concern about local air quality, these emissions create a real cascade of financial consequences. Midstream companies face incremental regulatory compliance costs just to monitor and report this stuff. They often have to absorb increased operating or capital expenditures to upgrade their equipment, and if they fail, no way around it, they face steep regulatory or legal penalties. And since air quality rules change from state to state or country to country, these financial effects vary heavily depending on the exact location of the pipelines and terminals. If we compare the two approaches, midstream operators basically fall into one of two camps. First, we have passive compliance. This means a company is simply absorbing those incremental regulatory costs, exposing themselves to legal penalties, and just kind of dealing with constant operational risks. But the other approach is active management.
This is where companies strategically use technological improvements to actively mitigate these adverse effects. They're turning a heavy regulatory burden into an actual operational advantage.
Section 5. Turning compliance into efficiency.
How exactly does a smart midstream operator turn incredibly strict air quality compliance into a competitive financial edge? Well, as highlighted by the SASB standards framework, tracking these metrics isn't just some feel-good environmental exercise. It is a fundamental necessity deeply rooted in financial materiality. The standard forces entities to look at sustainability data through the lens of cash flows, access to finance, and the cost of capital. Protecting the air is quite literally linked to protecting corporate finance.
Look at this quote pulled directly from the SASB Air Quality Topic Summary. It's absolutely vital. It says, active air quality management through technological and process improvements could allow entities to mitigate the adverse financial effects. I mean, that is the playbook right there. Proactive management, like installing better leak detection, upgrading to lower emission compressor engines, or optimizing natural gas processing, these are the exact tools companies use to blunt the financial impact of strict regulations.
Ultimately, the operators that truly grasp this realize a massive compounding benefit. By investing in process improvements today to reduce those localized NOx, SOx, and VOC emissions, they aren't just dodging fines. They are designing operational efficiencies that result in a structurally lower cost base for the future. They run cleaner, they run leaner, and they run cheaper over the long haul.
Which leaves us with a critical question to consider about this hidden bottom line. Whether you're an investor evaluating a midstream company or a community member living right near a storage terminal, are the operators in your area proactively managing their emissions through technology for long-term efficiency? Or are they just passively sitting back, waiting to react to the next costly regulation? It's a question of both environmental health and financial survival. Thanks so much for joining me for this explainer.